Tell me when you're starting.
Hi, everybody.
Sorry.
Welcome to another fun evening of scientific notation. I'm sure you're sitting there wondering why I'm wearing sunglasses. Well, if you want to know why, it's because people who work with teeny tiny things, which is what we're going to talk about today, teeny tiny little numbers, little things, have to wear protective eye gear like this in order to make sure that they don't affect the little teeny tiny things they're working with. And I am so totally cool that I'm wearing these sunglasses during this video. How much fun is that? Anyways, last night you learned how to write big, huge numbers into scientific notation to make it a little easier. Well, tonight you are going to learn how to write teeny tiny little numbers into scientific notation once again so we can write them in an easier way. So let's take a look at how that's done. Okay. All right. Have you ever, there we go. You got a cell phone, then you're used to technology called nanotechnology, which is the newest form of engineering. Nanotechnology works with numbers that are so unbelievably small, they need to be written in scientific notation in order to understand what the number actually is. The best part is that writing the small numbers in scientific notation follows the same steps as large numbers. I know you're probably so excited because it's totally going to be easy for you tonight. So what you do have to remember is like a number line, though, it's going to be in the opposite direction. So we're going to check some out and see what we're talking about. Oh, there's a number line. There's a picture for you. Okay. All right. Let's think about our hair. Think about how wide a human hair is. It's not very wide, is it? You probably could not measure it with a ruler. It's actually 0.0018 centimeters. Holy moly, that's small. But how can we write this number in scientific notation? Let's check it out. First thing we're going to do, step 1, is we're going to write the first factor as a number between 1 and less than 10. This should sound very familiar because we were saying the same thing when we wrote large numbers into scientific notation. So once again, that first factor always has to be between 1 and less than 10. So now that we're starting with a decimal, which way do you think we're going to have to move the decimal point tonight? Let's look. Here's our original decimal, 0.0018. Notice where the original decimal is. It's in front of that first 0. Now, where would we have to move that decimal point in order for that number to be between 1 and less than 10? Well, we'd have to move it between the 1 and the 8 because 1.8 falls between 1 and less than 10. So that becomes our new decimal point. So we have to move the decimal actually to the right. Now, last night when you were doing big numbers, you were moving to the left. So remember, tonight when you're working with very small numbers and you're changing them into scientific notation, you have to move it to the right. So our first factor is 1.8. Now, we're going to take that original first factor, and now we're going to see what power of 10 we're going to multiply that by. So here's our number. Now remember, once again, I know you're seeing a weird looking number with 2 decimal points in it. And that's because I still kept the original decimal point and where our new one is located. So step 2, to find the power of 10, you're going to count the number of decimal places from the original decimal point to its new placement. So here's our number. 1, 2, 3. Notice we moved it from the original decimal point on the left to the right 3 places. So, since you moved the decimal point 3 places to the right, our exponent's probably going to be 3, right? Come on, think about it. You started with a decimal between 0 and 1, and what kind of exponents produced fractions when we did our exponent unit? Try to think. What kind of exponents produced fractions or numbers that were between 0 and 1? Negative exponents. So the exponent is actually going to be a -3. So when you move the decimal to the right, the exponent will actually be negative. So our second factor will be 10 to the -3rd power. So if we know our first factor is 1.8 and our second factor is 10 to the -3rd, that brings us to step 3, which is writing the 2 factors as a product. And try to remember, a product is the answer when we multiply. So here it is, 1.8 times 10 to the -3rd. Now, in order to prove that, if you have your handy-dandy calculator, you can go ahead and multiply 1.8 times 10 to the -3rd. And guess what you're going to get? Your original decimal, which was 0.0018. Now it's your turn. What I want you to do is convert the following from standard form to scientific notation. Remember, you're going to pause the video, you're going to try to do them on your own first, and then you're going to come back to get the answers. So right now that I've given you those 3 decimals, I want you to go ahead, pause the video, and give it a try, writing them in scientific notation. See you in a second. Okay, hopefully you paused the video. Let's look at the first one. If we look at, and I don't even know if I can read this one. This one's really hard. So let's see if we can read this. Wait, hold on. Oh, shoot. Hold on. I can't even write right now because my bamboo board is not even hooked up. So hold on, my friends. Don't get impatient with me. I know you're all impatient right now. Don't be impatient with me. Don't be impatient. Oh, I can't see because I have my sunglasses on. Okay. Hopefully now it'll work. Does it work? Oh, there it is. Yay! Okay, so let's look. Our original decimal point is here. We know our first factor has to be between 1 and less than 10. So in order to do that, we need to move the decimal point so that it's located here. Ooh, isn't 1 between 1 and less than 10? I hope it is. So let's count how many places we moved. 1, 2, 3, 4, 5, 6, 7. So let's hope our answer matches what we got. Ooh, 1.0 times 10 to the negative 7th. Remember, it's going to be a negative exponent because we're moving our our decimal to the right. Let's look at 0.234. Where can I move the decimal point so that that number falls between 1 and less than 10? Exactly. I can move it right here between the 2 and the 3 because 2.34 falls between 1 and less than 10. How many places did I have to move the decimal point? Bam! I only had to move it once. So if I'm going to write that out into scientific notation, it'll be 2.34 times 10 to the negative first. The negative first is there. The negative 1 is there because I had to move it to the right 1 place. Let's look at the last one. Our original decimal point is in front of that first 0. So in order to make that number between 1 and less than 10, I have to place that decimal point between the 4 and the 1 and the 2. In order to do that, I actually have to move my decimal point 1, 2, 3 places to the right. So my answer should be 4.12 times 10 to the negative 3rd. Hopefully you got all 3 of those right. If you didn't, you might want to go back and check out the other part of the video again, just to reinforce what we're trying to teach tonight. So here comes your focus question. Are you ready for it? Here it is. How do we convert very small numbers, decimals between 0 and 1, from standard form to scientific notation? Go ahead and summarize those steps the best you can, and hopefully tomorrow we're counting on you to have that completed so that you can share with us your answers. Remember this little fun fact. You need to stop daydreaming about math and English. Really, Mr. Urbanski doesn't like it. Shh, don't tell. Don't tell if you do start to daydream. Don't tell him. But stop doing it. You need to pay attention. See you tomorrow. Have a great night. Bye-bye.